And I think Jeanette covered it really well as far as thanking everybody. Thanks to NASA, thanks to LPI, all of our participants. We know that you have a choice in how you spend your time in these busy times, and so we appreciate you patching in and contributing to what we feel like is a really important discussion moving forward. So I'm Jim Skinner. I'm at the USGS here in Flagstaff, Arizona. I am the coordinator of the USGS NASA Planetary Geologic Mapping Program. And it's always nice to mention that, I might be the person talking, but I'm backed by an extremely adept team here at the USGS and some very close collaborators in the community. So the things that I say here are often based on conversations that we've had broader than me. So yeah, let's just move forward. So next slide, please. So geologic map, this is not to insult anybody's intelligence here, but just to get the basics down and out of the way. A geologic map is basically a chart that's recording bulk geologic observations. And this is the character and the formative history of any particular area. That area is selected. It also has to do with the application of the observations within that. It could be resources, it could be other things, but it's basically context. We are providing context. I always like to mention that geologic map is a function of three different things. It is the map proper. And so when we talk about a geologic map, it's not just the cartographic product, it's the map, it is the descriptions, and it is the spatial and temporal correlations that go along with that. So the application of geologic map is a function of these. Slide, please. I like to throw this slide up, and it's a lot of words, and I'm going to read it. I typically don't do that, but I think it's important to get an idea about when we're talking about geologic mapping, especially on other bodies, what are we actually talking about? We often get comments about, can you do geologic mapping on other bodies? We're not going to get into the whole process orientation of things until we get to some specific talks, but yes, it is totally possible to do. There were a lot of heavy hitters that were participating in this work early on for Apollo, and one of the best quotes that we've seen so far is this Wilhelms and Macaulay quote from the near-side geologic map. And what they were saying was the goal is to portray units that are not just similar appearing surfaces or collections of similar topographic forms, but rather three-dimensional bodies of finite horizontal and vertical extent. And those are the building blocks of the visible part of the crust. So when we talk about geologic mapping, we're not talking about circling like features. We're talking about things that exist in three dimensions. And then you add that fourth dimension with time. So this is an excellent cutaway looking at the near side of the moon. It's Delisle crater, about 25 kilometers in diameter. And what you can see is 1 through 5, and it's basically just a sequence of materials and events. And they have a three-dimensionality to it. So when we talk about geologic mapping, this is what we're talking about. It is totally possible to do. You just have to hedge your bets a little bit and use some objective descriptions. And so we proceed with this as the intent of how we prepare maps. Next slide. So it's important also to note that on this eye chart, geologic mapping of the moon has been done, right? And so we're not talking about some reinvention of geologic maps. They have been done. We certainly need to do more, but in a kind of a chronologic standpoint, Hagman and Mason in 1961 produced a geologic map of the entire body. It was kind of a 4-sheet product, 1 to 3.8 million scale. We have colleagues across the globe that were participating in these efforts. This was followed by 36 LAC, this lunar astronomical charts, published at 1 to 1 million scale that were then compiled into a 1 to 5 million scale map of the lunar near side. That's that Wilhelms and Macaulay map. There were correlative maps that were produced at 1 to 5 million scale for both the east, west, north, south, and the far side, central. These were compiled later on by Corey Fortezzo and others into a 1 to 5 million scale global. The unified map is what we refer to it. Jim Head and others contributed to a 1 to 300,000 scale map of the lunar South Pole, and Jim will be talking about that later on in another session. And then our Chinese colleagues published a 1 to 2.5 million scale global map in a science bulletin last year. These are just a sampling of what has been going on over the past 40 or 50 years. There are many other products, including Apollo products that were published at 1 to 250, 50, and 25,000 scale. We have morphologic maps that have been published. One of those will be presented by Hannes. And then we have topical science maps that can be used and integrated into geologic mapping. Wes Patterson and some other folks might be presenting on that later on too. So the point here is that we have geologic maps of the moon. We have them at a diverse scale. Next slide. Relevance. When we talk about relevance, is the overlap between information needed and information provided. What we want to do is squeeze those two circles together to make them as most relevant as possible, so that people that need information are getting that information. There are multiple places where you can find descriptions of map relevance. Here are some. The National Geologic Mapping Act of 1992. Our colleague from USGS headquarters, Dave Soller, will be talking about this in another session. But basically, geologic maps are the primary database for virtually all applied and basic earth science application. And this is a U.S. federal law. Societal value of geologic maps, a USGS circular in 1996. This actually tried to put some evaluation of economic impact on the geologic maps. A really interesting read. It talks about putting a dollar value on what these products are. The value of geologic mapping has been a GSA position statement starting in 2003 and renewed 4 different times since then, including last year's most recently. This talks about public investment, enhanced partnerships across multiple institutions, digital access and interoperability of those data sets, as well as teaching these skills. And so calling on our university colleagues to make sure that we are teaching these skill sets so that we can not lose this as an integral part of what we do. And then the logic of geologic maps, 1974, a USGS professional paper, basically talking about how you can transform geologic maps into other products by essentially assigning new attributes of engineering performance. And we have Sarah Seitz and Josh Koyan will be talking about engineering properties of geologic maps and how they can be used for lunar exploration. And then finally, the Artemis Science Definition Team in 2020 came out with this document, an excellent document that summarizes what our goals are moving forward. And in there, they quote that it is vital that more detailed geologic maps of candidate landing sites be accomplished at a scale similar to what was done for Apollo. But et cetera, there are many, many other map relevance documents that go along with this. Next slide. So map purpose, this is one of the themes that you'll hear me at least harping on through this workshop, is that there's 2 different things going on here: fundamental science, maps guide context, and is a way to document geologic phenomena. Okay, so that's basic fundamental research. But there's also the other side that we haven't quite recognized how to get into yet. This is applied science. And so how do we make these geologic maps from research into application to satisfy things like exploration, resources, hazards, and then to assist with traverse planning, civil engineering, site development. On Earth, geologic maps are used for these purposes. Right now, we are in a place for planetary geologic mapping where we are still documenting phenomena and are just starting to scratch the surface of applied science. And so you will see this come up over and over again. What we want to do is understand what this means. But I think that there's no doubt and no question about that sustained presence on the lunar surface requires an understanding of the geologic environment, and that's at multiple scales. Next slide. So challenges, we always have challenges. These are from the workshop focusing questions. So lunar geologic map production is out of sync with the data volumes, diversity, type, and exploration needs. This is a common problem that we have on multiple planetary bodies. We have a ton of information, and how to be able to decipher that to get good science out of it, not just geologic maps, but everything. So it's hard to coordinate all of these different observations so that we can make product. In the case for this workshop, we're talking about geologic maps and how we can make those so that we can support exploration. As I said before, applied science content is just not well recognized. We can recognize that it's needed, but we don't quite recognize what that might be. And this is in particular regard to map scale. Stakeholders is another word that we use quite a bit. Stakeholders are not fully recognized either. And so that goes hand in hand with content. So they're not fully recognized, and that means that stakeholders are not collaborating. And collaboration is really what we're trying to get at here. When we talk about stakeholders, we're talking about the contributors and the preparers of geologic maps, as well as the users of those products. Also, the timing constraints on product delivery, that's something that we are struggling with, understanding how to get at this information. When do the maps needed, where they needed, and who needs them. Next slide. So the goals of this workshop, obviously bring together the science and technical professionals, determine who the stakeholders and the map users are. We'll get back to that whole thing about content and scale. We want to identify a timeline for map production, start assessing the bottlenecks for the production of these maps and start to dislodge them. And then recognize that geologic maps are basic and applied science products that improve both science and reduce risk. And this is going to be important moving forward. Next slide. So in the end, just to kind of kick things off here, this is a start of a cross-discipline discussion. This is the start of what we hope will be a collaboration. These are both near-term and intermediate and long-term needs with geologic mapping that we want to recognize and start to slate out. And just also emphasize that there's quite a bit of urgency to these topics. And so we want to get the information out there and start this collaboration. So looking forward to this. Next slide is a bunch of references for map process. People can visit that later on. Thank you.